Hello, good evening everyone. We will wait for more 5 minutes for others to join. Anyone please confirm if I am audible. You can write in the chat.
Yes, you are audible.
Okay, thank you. Yeah, hello, good evening everyone. So this is the course of Solar Photovoltaics Fundamentals, Technology and Applications, which is being taken by Professor Soumitra from IIT Roorkee Department of Physics. And I am Ravi Kumar, a PMRF research scholar at IIT Bombay. So in these classes, I'll be discussing some questions, some concepts related to the course. And few things I just want to tell you. I want these classes to be more interactive. You can speak or you can write in the chat box. We will be having some discussions. I'll throw some questions on you and you have to reply or respond on the chat box, or even you can speak. So course says solar photovoltaics. Does anyone knows what does the meaning of photovoltaics? What is the definition of photovoltaics? Let me open chat box. Yeah, chat box is like in front of me. You can write in the chat box. See, this is not a regular class. Regular class we already have on the NPTEL website. So these are some discussion classes. Yes, electricity is generated from light. Okay, Vinod Kumar said, great. So have you seen this photovoltaic technology anywhere? You must have seen, I think, because it's 2023. Yes, no? Silicon solar cells. Solar panels, yes. Vinod, you are right. Shruti, you are right. Silicon solar cells. We see solar panels. Solar panels, Radhika, right. I hope you have gone through the lectures related to this first week. Yes or no? Chetan Yadav, solar panels, yes. Okay. Yes, great. Okay. Okay, then let's start solar photovoltaics. So first we will discussing about this renewable and non-renewable sources. So give me few examples of renewable energy, non-renewable energy sources, and let me know the difference between these two. What do you think about this renewable word and non-renewable word? If I am saying some sources are renewable energy sources, some sources are non-renewable energy sources. So what do you understand from them? Give me definition, give me an example, anything. Vinod Kumar said renewable means something that can reproduce within a short period. Absolutely correct. See, renewable means that can be created again and again. But the major factor is time. How much time it take to reproduce. So if it is a short period, then we say it is renewable energy source, and if it takes long time, it is non-renewable energy source. If you are going just with the definition of renewable, like meaning of the word, then coal is also a renewable energy source. Oil is also a renewable energy source. But if we take time in consideration, then they are not renewable actually, because they take so much time to regenerate. B. Madhumita said renewable energy means resources that can be regenerated again and again. Yes, but time, within a short period of time. Deepshika said example of renewable is solar energy, wind energy, right? Let me write solar energy and wind energy. Give me more examples. Fossil fuel, renewable? No, not non-renewable. Inside fossil fuel, what we can have? Coal, oil, tidal energy. or we can say biofuels, hydro, tidal energy, tidal already written, which are extracted from earth's surface and cannot be reused. Okay. Okay, I have written few examples. Something missing? No. Now, just let me know one by one how. Okay, I'll come to this question after few slides. So, right, you understood renewable and non-renewable. Here, time is crucial. It takes short period of time and it takes very long period. Petrol, diesel, natural gas, non-renewable. Okay. Okay. So let's move next. Why renewable sources of energy? Why we are like running behind these renewable source of energy? What are the reasons? Why we are focusing on solar photovoltaic? If we have coal, if we have petrol, diesel, why we are not just living with those? What is the reason behind this? See, if you are like learning about photovoltaics, then there should be some reason. Environmental friendly, it's pollution free, right? They are limited. Okay, non-renewable sources are limited. Yes, there are two major reasons. One is like environmental friendly or causing pollution, and other is limitation with respect to non-renewable sources. Not renewable are limited and non-environmental. Okay, sorry. Non-renewable are limited and non-environmental friendly. Okay. Okay. Yes. So, how a coal is impacting our environment? You must know it. I'll just go through it. So, we have some greenhouse effect, and what happens from these fossil fuels? We got these gases, and what these gases do? They absorb the long wavelength which is reflected from the surface of earth, and that's why the temperature of earth is increasing. Okay, let me tell you one thing more. Like after these classes, every Friday, just after the class, I'll upload the PPT and I'll upload the video, like recording of these lectures on a YouTube channel. So it's like YouTube channel only for these NPTEL classes only. And this is the link which I have given you in the chat box. So by chance if you miss any lecture, you can go through on the YouTube. Any question here? No. Yes. No. Okay. Now let's come to the ultimate source of energy. You said we have tidal energy, we have hydro energy, we have fossil fuel, we have solar energy, we have wind energy. But what is the ultimate source of energy? From where this energy is coming? So for this, I'll do some a little exercise. Let's say wind energy. Wind energy is coming from wind. B. Madhumita and Vinod, you are right. Wind energy is coming from wind, and wind is flowing due to difference in temperature, and which is causing due to sunlight. So differential heating of water and land leads to the wind, and this wind we use at wind energy. Second, we can say bioenergy. So it's very simple, like we have photosynthesis, and this is coming from sun only. Third, we have like solar energy, that is coming from directly from sun. So I just want to say the ultimate source of energy is sun only. Even if it is fossil fuel, even if it is bioenergy, wind energy, tidal energy, or anything. So if sun is the ultimate source of energy, then we need to know a bit about sun. So this is the latest picture of sun. This is the current image. It is taken on 3rd February 2023, and you can get these pictures from a link I'll provide in the uploading PDF. Yes, if you will search na is sun latest photo or image, then you will get a link. From there you can see. So what is the sun consist of? If everything is coming from sun, then what the sun consists of, and what is the source of energy inside the sun? This is a major question. If everything nuclear, it is just half part. Pankaj, you are right, it's nuclear, but a bit more. Fusion, yes. Many elementary particles and dust. Okay, you are saying, the Madhumita is saying it consists of many elementary particles and dust. Fission and fusion of hydrogen. Vinod Kumar, can the fusion of hydrogen take place? Yes or no? No. Then fusion of hydrogen is not right. You must have seen the latest movie Oppenheimer. I don't know if you have seen it or you have watched it or no. Okay. So it says isotopes of uranium, they are like dividing, that is the fission. Here is fusion, yes. So it's like 90% of sun is consist of hydrogen and 9% is consist of helium and 1% is other particles. So this is the hydrogen fusion take place. and we get energy. So ultimate source is the nuclear energy. Yes. Is there any carbon and nitrogen? See, just think a little bit about carbon. If like human body is made of carbon, if it will be going at higher temperature, what will happen with the carbon? Carbon is like an hydrocarbon, no? So it should not be there. It's like the most elementary particle, that is the hydrogen. Okay, let's move a further bit. So what happens in a solar photovoltaic? Let's come to the photovoltaic only. So now we have seen sun, and we need to catch the energy, or we need to harness the energy from the sun. So there are many ways. Like wind energy is ultimately harnessing the sun energy. So there are other ways which are direct. Those are, we say, solar energy. But it depends on the irradiance. So this is the irradiance distribution around the world. So you can see this is an scale here. This is the maximum and this is the minimum. So these countries are receiving maximum solar irradiance. Solar irradiance, you understand? Yes or no? If no, it is just the, yes, intensity of sunlight, we can say. So this is maximum here, and a major part of India comes in this region. So India is a, then what we can say about India? Should we go with the photovoltaic or no? Yes. That's why we are talking about this photovoltaics these days a lot. We have different schemes related to solar, and like focusing on the photovoltaic energy, we have rooftop solar scheme, we have like solar tubal scheme. So there are so many schemes we have to do. Okay, now I'll tell you, we started with the sun, we are receiving some irradiance. Now we will see how can we use this irradiance. So there are two ways. One is known as thermal and another is known as photovoltaics. So in the thermal energy, what we do? Anyone having any idea? Yes, no, maybe? Thermal energy. Thermal and photovoltaic, these both are solar energy, but different mechanism. Okay, Pankaj said no. Direct use of heat in sunlight, yes. But how they use this heat? Do you have any idea? No. Okay. Okay. See, thermal energy, we have different kind of like technology we are using nowadays. So these are rooftop solar water heater. So here what happens? We have evacuated tubes. They are having some energy fluid which heats up due to sunlight and which heat the water inside the tank. So this is solar water heater. Then on the large scale we have this parabolic trough, and we have solar tower. So what happens in the solar tower and parabolic trough? If sunlight is coming like this, it will be concentrated here, it will be concentrated here, it will be concentrated here. So all the sunlight, it's like coming and concentrating, coming and concentrating. So they are concentrated on this pipe, and in this pipe we have a high energy fluid which got heat up, like it got heats up, it heat, then it makes water into vapor, and this steam and this steam is used for turbine, and we get electricity. This is one way how we can harness the sun and sunlight or sun energy. Similar way, this is parabolic trough. We have this solar power tower. What happens? We have small mirrors like structure, these, and sunlight comes here and it got reflected at one place. So every glass or every these mirrors reflect the sunlight at a particular spot. This is the spot, and at this spot there is temperature is very high, and this temperature is used in the similar way: high energy fluid, then heat, then steam, then turbine, then electricity. But there is a catch. If we don't need electricity, we just need heat. Where do we need heat? Industry. So in so many industries, we need just heat, or we just need hot water or steam. So what they do, they just stop here. They just use this steam for their industrial purpose. So if their requirement is just heating water or just steam, so they will use this solar thermal energy. They will not use this solar photovoltaic. And this picture is for solar photovoltaic. You can see this is a solar park. So this small thing is a module. We can say PV module. So like these are the two ways by which we can harness the solar energy. Any question here? Yes, no? 6:30. Okay, Vinod said no. So you got it? How we can harness the sun energy in two ways, or solar energy in two ways. Okay. So now there is a question for you. Because you understood sun, you understood the radiation coming on the earth. So this is a question for you. What are the factors influencing the solar irradiance on the earth surface? You have seen solar irradiance map around the world. So you must know what are the factors which are influencing this solar irradiance, and these are the options. And just let me know how many. This is a like multiple type question, so there are multiple solutions, or multi options are correct here. What are the factors which influence the solar irradiance? Is it absorption, scattering, day of the year, wavelength, type of receiving surface, or time of the day? It's very simple. You just all of them. No, Deepsika, it is not all of them. It is not that simple. See, just imagine you are living at your home. Then what do you see? On the cloudy day, what happens? How like sunlight reaches on the surface? In the winter, what happens? In the summer, what happens? In the day, what happens? In the night, what happens? Yes, just need to a bit cautious here. Someone saying, Radhika is saying time of the day. Absolutely right. Because now it's 6:30 at your place and sunlight is like having very minimal irradiance. So it's time of the day. Absorption also, Radhika said absorption also. Vinod said F. Yes, time of the day is correct. But let me mark. Time of the day. Someone said absorptions. Can you clear what is this absorption means? If you have any idea. What type of receiving surface? Type of receiving surface. Really? If you are standing on the terrace and if someone else is standing on the terrace or you having some kind of other surface, so irradiance will vary. Maybe the sunlight which is absorbed by it. Okay. Day of the years. Is Sarath. Sarath, sorry. Is Sarath said day of the year. Day of the year is right. And who are saying Radhika? Radhika is saying absorption. Yes, it is correct. It is like we have multiple layer in the atmosphere and they absorb some sunlight. So if they are absorbing more, then sunlight reaching on the surface of earth will be less. Because question says surface of the earth. Time of the day, day of year. Susrut Mane said B, scattering. Scattering from layer of atmosphere. Yes. Scattering is right. Okay, if there is more scattering, then the solar irradiance will be more or less. Less. Everyone is saying less. But there is a catch also. I'll tell you in the next slide. We have different kind of radiation. So one radiation will increase and other will decrease. So I think like we are done with this absorption, scattering, day of the year, time of the day. Note the type of receiving surface and note the wavelength of radiation. So scattering all done. See, this is a very important. Longer platinum will pass. Where it will pass? Even after scattering. Okay, you were telling about this scattering thing. Okay. See, here you can see if we are having 100% outside the earth, then how it will be come to on the surface? So it's like 2% will go, 18% will be absorbed here. It's like 2% in ozone layer, 1% upper dust layer, 8% air molecules, 6% water vapors, and 1% lower dust layer. And these are the scattered to space, and this is scattered to earth. Direct to earth will be 70%. Okay, now we were talking about this scattering. So, oh, it's in front of you only. Types of radiation. We have direct radiation, indirect radiation, and global radiation. Anyone know what is direct radiation, indirect radiation, global radiation? Having any idea about this? Okay, tell me one thing. It's 2 p.m. in the afternoon. You are sitting inside your room, but it's like you are in your room. There is no direct sunlight, but some light is there. Even then, you don't need any light to lit up. Why? Why inside your room you don't need light at 2 p.m. in the afternoon? It's like I'm saying one particular instant. It's not like exactly 2 p.m. It's like all over the day. Because some light comes, reflected sunlight is lightening the room. Yes, Rustwane, you are right. Light diffraction. Light diffraction. If you are saying light diffraction, it means the exact intensity should come to your room. You must have like learn about this Young modulus experiment and all. Light diffract, but very less. Diffraction is very low. Direct radiation means which does not experience scattering. Vinod, I think you understood diffraction is not light. If you have doubt, I can like explain more. Sound diffract more as compared to light. That's why even someone is saying anything in like outside my room, I can hear. Okay. Radhika, direct radiation means which does not experience scattering, right? Okay, so direct you said which does not experience scattering. Now comes to indirect radiation. Chalo, let's take an example. You are having a solar panel at your home. It is like installed on your terrace. So which radiation it will use? Direct, indirect, or global? Indirect. Then why we need to put it on the terrace? We can like keep it in the room if it is using indirect. Do you know if a solar panel can be kept inside a room, then the cost will be much lower and other impacted factors like dust, rain, soil accumulation and other defects and degradation will be very less because it experiences harsh environmental conditions. So sometimes solar panel fails. B Madhumita, you are right, it's saying direct, but it is not like absolutely right, but you said direct. Okay, my first question was like, you are sitting in your room, it's 2 p.m. and light is lighting up your room. So those radiation are indirect radiation inside your room. And if you will go out and you will face the sun, then that is the direct radiation. And if any surface is having both radiation, direct plus indirect, that is global radiation. If this is sun, my drawing is not good, and this is a solar panel, we can say. So these are the direct radiation. And let's say we can say there is an obstacle, or we can say there is some home or like house of someone else, and light is coming from here, and it is after scattering, it is coming from like from all directions. This is indirect. And direct plus indirect equals to global. Global is both direct plus indirect. Any doubt here? I don't know if you are enjoying or not. Let me know. If it is monotonous, then I can change the pace and I can change the thing. Okay, so it is direct and indirect radiation. Okay, thank you. Which sum up to make global radiation. Okay, let's move to the next. So any one of you, have you seen solar panel? Like, have you touched the solar panel ever? Okay, so have you seen like a chit behind the solar panel? Okay, so next question is based on that only. Okay, first question is very simple. So what is the mean solar irradiance, solar constant, that is known as, what is the value of this? And these are the options. So you must know how much energy we are receiving on the earth. Because if you know how much energy we are receiving on the earth, then only you can calculate how much power you require, how much solar panel you require, all those things. I don't think you like know this, but this question is just to tell you, it's like 1367 watt per meter square. It is the energy we receive on the earth. Vinod, you are saying A. Yes, usually, but ideally. Usually it is like place to place it vary. It's like 1000, sometimes 800. Okay. Yes, I was talking about one thing, that is the seat, or like one label seat behind the solar panels. So they are having one thing, it says 300 watt at STC condition under 1.5 AM. So this is written on the solar panel. So we understood this solar panel will generate 300 watt when STC means 1000 watt per meter square irradiance or 25 degrees Celsius temperature if these conditions are met, but under what? 1.5 air mass. So what is this 1.5 air mass? We understood this. What is this? Okay, it's like related to some geography thing. We can say if this is Earth, this is X, this is Y, and Sun is there and Sun is there. At one time it is there, at second time it is there. We can say this is an angle. So what happened? It should be like this. It should be like this. Sorry for the drawing. Because X will be always less than Y. So at this position, this is the length the sunlight need to cover. But at this position, this length is that much, Y. So it says when the position of sun is here, under these circumstances, we measured the power of a solar panel. So it is always like X by Y. It is the ratio when the sun should be exactly at zenith angle. What is the zenith angle? What is the zenith angle? Okay, you don't know, it's okay. So zenith angle is the angle when sun is like on our head. In this condition, X less than Y is based on length. Yes, based on length. It says it is the right relative position of sun with respect to zero zenith angle. If sun is on my like just above the head, then zenith angle will be 0, and if the sun will move in direction or is this direction, then the zenith angle will be changed. So like this theta is our zenith angle. So this air mass nothing, just an ratio of zenith condition with normal condition. So that's why this is defined as cos theta equals to X upon Y. This is just talking about the environmental condition. Okay, next question will come on this AM. I'll tell you there. It is just talking about the environmental condition. Where is the sun? So the question says the zenith angle is 48.2 degrees Celsius. It is our theta. Then what is the value of air mass? You can calculate. Just put here. I am saying X with respect to Y. So we can take X equals to 1. If we will take X equals to 1, then the cos theta equals to 1 upon Y. And theta is given, so Y will be cos inverse 1 upon theta. Tell me the value. Cos inverse 1 by theta. Anyone is calculating? No. Here is my calculator. I don't have right now, but yeah, okay, it's 48.2, so I think it will be 1.8 1.5. Anyone please confirm if you are calculating it. Okay, 1.5, right. This is the same thing which I told you. It's like air mass represent the, it's like proportion of atmosphere that the light must pass through striking the earth related to its overhead path. Overhead path means zenith, zero zenith angle condition. B Madhumita, right, 1.5. Yes, 1.5 is the correct answer here. Now, yeah, next question says energy means irradiance with air mass. Will it increase, decrease, remain constant, or none of the above? What do you think? Like it says, if sunlight is going through 1 kilometer of air mass, and if it is going from 1.5 kilometer of air mass, then the irradiance in what condition will be more? Just like try to remember the picture which I shown you. One. Okay. So the question which I asked orally, you are right, it's one. And now comes to this question. So energy with air mass will increase, decrease, remain constant. Chaitanya, you are right, it's one. But according to this question, it will increase, decrease, or remain constant. Decrease. Decrease, decrease. Okay, decrease. Yes. It will decrease. Even we have this formula. Using this, we can calculate. It will decrease. Very simple question. We are moving to the next question. Which one is not belongs to the pole? And these are the options. Peat. Yes. Yes. Then what is this peat? What is this peat? If this is not a coal, then what is this? Yes, Chaitanya, it is the first stage during coal formation. It means you have gone through the lectures carefully. Rotten waste. Yes, we can say rotten waste. It's the first early stage. So yes, peat is the correct answer. C. Next question says, which of the following is considered a renewable energy source? And these are the options. Renewable energy we just talked in like in the starting of the lecture. It's natural gas, coal, solar power, or petroleum. Solar, solar, solar. Everyone knows solar. See, there are 26 students, but I received only 5 or 6 responses. It means other don't know this question, or they are too much shy to like give response. It's okay, I'm just kidding. Okay, see, solar power is right. It's C. Okay, next question. The photovoltaic effect is used in which type of renewable energy technology? And these are the options. B. Solar panels. B. Akhilesh, Sriram, Mamta. So many responses. Chetan, Mareswari, Madhumita, Deepshika, Radhika, Guru. Mahalakshmi, yes. Yes, solar panel. But do you know what is the material of these solar panels or how it is formed? Do you have any idea? Silicon? Silicon? Okay. So we can say semiconductor. Semiconductor. So if I'll be having a silicon sheet and I'll put it in the sunlight, will it generate electricity? No. Doped silicon. Even I doped it, then will it generate electricity? We need junction. Yes, we need junction. Then you know diode, collecting terminals. Semiconductor is nothing else, it is just a diode having a large surface area. Just a diode. I don't know if you know it, but in 10th standard, what I did, I took a like power diode we have in so many instruments. Then I cut it the top of this power diode. They are having some kind of covering, and then I just tried it by putting in the sunlight, and I measured in the like galvanometer, so it deflected the galvanometer. PN junction diode. Yes. PN junction diode. Yes. I'll tell you more and more about this. Okay. So this is B. Oh, so sorry. Next question says, I'm sorry, it is already visible, but it's okay. Let's do it. What is the maximum theoretical efficiency of a solar cell based on Shockley-Quasar limit? 33. Yes. Even this is the solution, like 33. Above this, below band gap photon will start. They will not contribute in the electricity generation. Yes, it's 33. Yes, 33. Do you know the component of solar panel? We having a cell, but silicon is very fragile. Yes or no? Silicon is very fragile, and we can't just keep the silicon or doped silicon or PN junction in the like harsh environmental condition. That's why we have a layer of encapsulate. Do you have any idea about those? No. Yes. Vinod Kumar said yes. So can you like name one or two things you know about this? What is the main thing which provide the stability or mechanical strength to the solar panels? What is the major thing? What is that? Silicon solar cell is very fragile. Even if you will just hold it, it will break. So there are something inside the solar panels which provide the strength. And you know it. You don't need to like, sir, I'm taking 2 courses, design of solar PV. Can we change time for this? Actually, like Hussein, I just want to tell you one thing. I'll be uploading videos after recording on the YouTube channel. You can access those videos later, but it is like very impossible to change the timing because we already submitted the timing to the NPTEL. And like this is the link for the YouTube channel. I'll upload this lecture even after the link I already given. Yes. Even before this, I took 2 more courses in the last semester and last to last semester. Those videos are already there, and from today onwards, this course lectures will be available there. Okay. 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 Thanks for understanding. Yes. Okay. I was talking about the solar panel and like solar cell and solar panel. What is the journey between this solar cell to solar panel? I'll tell you after like in the end of this class. Okay, now comes to few questions which are very basic to the quantum physics or quantum mechanics. So first question says the Fermi energy refers to, and these are the options. Sir, one more thing I don't know about timing zone. 6 p.m. in according to Indian time zone. Yes, yes, Hussein, it is Indian timing zone. Are you from which country? Everyone saying D, D, D. It means you know very well. Great. Okay, you are from Pakistan. Great. Yes, it's Indian Standard Time, IST, 6 p.m. Okay, I'll be uploading these lectures so you can just, even if you have any like doubt while watching those lectures, you can ask in the comment box. I'll reply there as well. Yes, everyone is right. Akhilesh, Guru, Chaitanya, everyone is right. Sorry. D. Answer is D. Okay. Next question says the Fermi-Dirac distribution function describes the statistical behavior for, and these are the options. C. Fermions. Wow, so many physicists. Everyone saying C, 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 C. Yes, it's good to see. C. Fermions. Okay. Next question in numerical. Take your time, solve it, and give me the solution. It says in a solid, consider the energy level lying 0.05 electron volt below the Fermi level. What is the probability of this level not being occupied by the electron? And these are the options. If you don't know the formula, I can give you the formula, but please try to solve it. Hussein, you already solved it, right? I solved this question. Yeah, if temperature is not given, just consider the room temperature. Or in Kelvin, it is like 300 Kelvin. It comes to 298 Kelvin, but just consider 300 Kelvin. I sold this temperature is not given, Mamta. Yes. Answer is not there in option. Yes, Hussein, it's actually 0.127. Yeah, Mamta, you are saying consider RT, but answer is not there in option. What is your answer? Can you just let me know? I understood where you are going wrong. Just tell me your answer. I don't remember right now. Okay, so based on my guess, you sold it. I'll tell you. So this is the first step, then second step, then third step, and then you sold it till here. And your answer should be 0.87. As like I understood where you can go wrong. But it is showing not being occupied. It is saying not being occupied. So 1 minus P. So it is 0.13. Yes, Shoshan, you can ask. Zero point zero. It's given now. It's saying below the Fermi level. So we have E minus EF. So if it is below the Fermi level, so difference should be how much? Yes, I'm telling you one thing. Just be attentive here. It says E minus EF, and it is saying below. If it is Fermi level F, and it is our energy level, and this difference is 0.05. So what should this E minus EF should? I got your point. Let's take this way. This is our Fermi level, and this is 0, this is 1, and it is saying energy level here, it is 0.05, and I am saying just E minus EF. So what it should be? E minus EF should be 0.05 negative, because E is less than the Fermi level. If it is, it said like above, it said above Fermi level, then we should put E minus EF equals to 0.05 without any negative sign. It's like it is Fermi level and our energy level is here. If we will like subtract this Fermi level from our energy level, will it be negative or positive? Because the energy level of Fermi is more from the energy level we are considering. It is Fermi level. If okay, you understood. If our energy level is above the Fermi level, it will be positive. If it is below the Fermi level, it will be negative. Okay, thank you. So answer is 0.13. Mamta, I think you also got your like and doubt corrected here. Yes, okay, thank you. Yes, answer is A. One more question. It says the Fermi energy of electron in a copper at room temperature is 7 electron volt. What is the de Broglie wavelength of these electrons? And these are the options. Let's say who has solved it already. Step I can tell you. First, Fermi velocity, then de Broglie wavelength. Yes, no? Okay, just see the screen. So this is the formula for Fermi velocity, and we are having like mass of electron me, and energy is already given. It's like 7 electron volt. We will get this, we will solve this, and we will get this Fermi velocity. Yes, you Mamta, you are right. That is the formula for de Broglie wavelength, second step. So first step is there. In the second step, it says h upon 2m ef. Your formula is right. So we will just put the value of h here, mass of electron here, 2m e f. Yes. Yeah, even we can just calculate from here h upon me and vf. Just put vf, me and h. And we will get 4.62 into 10 raised to the power minus 10 meter. That is 4.64 B. Okay, let's move to the next question. And this is the last question for today, but we will have a discussion about this like solar cell to solar panel briefly, how these formulas relate. Which one? This is the formula for Fermi energy. Yes, this is the formula of Fermi energy, and like de Broglie wavelength is nothing, just like h upon mass into velocity, we can say. And just velocity we just put it here. H we know is already a constant, and mass we already know from the electron mass. Okay, so density of state and all, this is the question. It says density of state in 2D, 3D, 1D is proportional to respectively, proportional to energy E, respectively. A, is it really A? Do you want to change your answer, Mamta? Me to sing. I don't think so. Okay. Chaitanya is saying B. More. Just look the picture. What do you say now? It is 1 by 2 with 3D and constant with 2D and like square root by 1D. So B, yes. Chaitanya and me too, it's right. Yes, Oshan, you are right too. So we are done for today. Yes, I was telling you, first just save this link for the future reference. Sometimes if you are not able to join the classes, you can watch them online. Second thing, as I told you, I'll tell you one thing. Yes, see, we have solar cell which is made of silicon. So I'll tell you in the reverse way. Reverse way means today I'll tell you if you have a solar cell, then what is solar panel, and then in further lectures we will go inside the solar cell. So it's like one solar cell, then we have array of solar cell, and this is a solar panel. We generally say PV cell. It is PV panel, PV module we generally say. So what happens? These are very fragile, which can break. So we need some mechanical strength. So what we will do? We have this glass. It's soda lime glass. So on this glass we have solar panels, and then we have a seed. Let me tell you this way. If this is a solar cell, then and this is a glass, this is solar cell, and above we have a one more seed that is known as back seed. But one main questions which should come in your mind, how a seed and glass can hold the solar cell. So in between we have some one more layer here and here, that is known as encapsulant. This encapsulant is like a glue. So what happens? We have first we put glass, then we put encapsulant, then we put our solar cell, then we put encapsulant, then we put backseat. So these layers, then we do lamination under a little bit pressure and high temperature. So in the high temperature, what happens? This encapsulant silt, it melts and it melts and it become a module. So everything is encapsulated. So these things will be in a one layered structure, one encapsulated structure. So here the strength is provided by the glass only. Encapsulant is just a layer and backseat is just a sheet. It is normal polymer type. You can fold that. So we just use this backseat to stop the water ingress and other gases from the backside or even UV radiation from the backside. So that's why we use this backseat. Any confusion here? or any doubt? If you have no doubt, then I am done for today. We will meet next Friday at 6 p.m. sharp. If you have any doubt later, what is B Vinod Kumar? It is not any question there. Okay, even if you have any doubt later, sir, can we ask doubts of lecture here? Yes, you can ask. Even, do you know we have a discussion forum for the doubts? Yes or no? Yes, even you can ask doubt on the discussion forum. Discussion forum is very important because at the discussion forum, including me, others members associated with this course, they can watch and they can reply as well. So that is more appropriate to ask in the discussion forum. But even if you have any doubt, you can ask here anytime. You can ask during the lecture on my YouTube channel or in the comment box. Timing is from 6 to 8. Generally it's 2 hours time, but sometimes we finish early. 6 Indian Standard Time. Pankaj, I think you are asking time for this class or you are asking for something else? Discussion forum. See, discussion forum is different thing and this discussion classes are different thing. Discussion forum you can ask doubt anytime. It doesn't matter. Okay. You are welcome. I hope you are not bored during the lecture. I'll try to make it more engaging. Yes, Chaitanya, ask. Others, if you wish to. Sir, I do not understand the K space volume. Okay. It was nice. Thank you. Okay. Yes, then I will include in the next lecture in a more interactive way so that everyone can understand because it is very crucial. K space time and all. Let me make a note of this. Informative, interesting. Thank you. One doubt is from K space. Okay. Other thing you want to learn in the next lecture or anything other than those doubts and other than those questions and all? You are welcome. Yes, it will be objective. Wait a minute. हाँ हेलो. यस. हाँ हाँ बताओ. डिपार्टमेंट के जो को हाँ. वो देखो एक लिस्ट होगी अपने उसमें जो मैंने अभी भेजा है. अगर कोई भी कोर्स उसके बाहर है तो वो इंस्टीट्यूट इलेक्टिव हो जाएगा. हाँ. हाँ राइट. हाँ हाँ. या थैंक यू एवरीवन. I'll try to make these lectures more interactive because it is good to learn and it is like I enjoyed while people respond. Thank you. Okay. Okay, let me end this class. If you have any doubt, anything to say, you can ask, or if not, then enjoy your day.